Hi, we're the team called The Guys of the Hood, and we are going to talk about the legal interruption of pregnancy in Mexico City during 2018. We chose this topic because we know the importance of it, and that it is a very popular topic for discussion in our modern history. We saw the opportunity to show if all the stigma and stereotype about what kind of woman has an abortion is real or if there is really no mold. We started with something easy. We wanted to see how many abortions are forecasted. So we used our knowledge from second partial and decided to do a simple exercise. But before we could do it, we needed to arrange our data. The database we used had more than 20,000 data, so we cut the sample to only 10,000. We separated the variables we were going to use in this case. They were month and number of abortions. The months was a qualitative variable, so we changed it to quantitative with a if formula in Excel. After that, we needed to know how many abortions were made in each month, and to do so, we used a simple formula of sum if. We had the months and abortions ready to use them, so like we learned during second partial, we manipulated the variable of abortions and made a column with the square abortion, so that we could have two equations. Then we realized we needed to know the m and b value to make the equation. That's why we used the intercept and slope formulas. We also realized that to analyze which data work better for forecasting, we needed to know the value of r squared. So we made the two plots and chose that Excel showed us the equations and r squared value. We concluded that in this case, the normal data work better for forecasting abortions. We obviously realized that to have a deeper analysis, we needed to make a more complex model with more variables. That is why we chose to do a multiple regression.
On this project, we had to additionally select some specific variables. We used education level, job, age, and some other variables from the original data. Then we ran a multiple regression with 5,000 elements. We took out the less important variables, which were the ones with less than 0.05 in p-value. In this case, civil status, education level, job, menarca, first sexual relation, and weeks since the last sexual relation were the non-significant variables. Then we ran the multiple regression model again and used only the significant variables. Also, we can see that the determination coefficient was higher in the second model. Then we got an abortion equation that is equal to minus 0.995, that is our interception, plus 0.0091 multiplied by h minus 0.872 multiplied by the number of children, and plus 0.8289 multiplied by the weeks of pregnancy. Finally, we fabricate a case about a woman with a kid and 2 weeks of pregnancy, with the objective of getting a probability of the chance of her getting an abortion, by using the exponential and receiving a data-specific number. This way, we found out that this specific woman, in this case, had a 80% chance of having an abortion. 83.
Then we got an abortion equation, which includes weeks of pregnancy, number of previous kids, age, etc. Then we fabricated a case about a woman with a kid and an X number of weeks of pregnancy, with the objective of getting a probability of the chance of her getting an abortion by using the exponential and receiving a data-specific number. This way, we found out that this specific woman, in this case, had a 0.83% chance of having an abortion. Finally, After analyzing the non-significative data, we can conclude that when it comes to women legally performing an abortion, there are many opinions on what makes a woman likely to have an abortion. However, these variables are not necessarily relevant. Even though people think that there are other relevant factors like age of first sexual encounter, education level, job, marital status, in reality, this project has unequivocally proved it wrong, defining other actually important variables such as age, children, and time of pregnancy.